You're back.
Hi again. Nice to meet you here. Hope this part won't be so difficult. Well, as we discussed, we will start from the question we already have in chat. Artem asks, can he use gRPC for his Xamarin multi-platform client and Netcore backend application?
Okay, it's a very good question. I'm not sure, but if you're able to show my screen, I can answer this question by showing you something. So when I built my Sauna application last year in .NET Core 3.1, I was having the same question. So I wanted to build a worker service and a gRPC service on the Raspberry Pi, and I wanted my Xamarin Android application to be able to connect to this a Raspberry Pi instantly, like using a gRPC channel. But at that time, I was not able because there was not yet support in Xamarin for HTTP2. So in order to have gRPC support in your client applications, you need to have HTTP2 support. So the platform that you are using needs to have this support. So today, I'm not sure what the story is. Actually, I'm planning to rewrite my entire Sauna application, or not rewrite. I want to upgrade my Sauna application to .NET 6 with Project Maui. So instead of Xamarin, I want to use Maui. And maybe then I can do something different with gRPC, but I haven't really checked yet. So the thing that I did today, and you can see that on my slides if you're able to see them, that is that I have an HTTP web API in between my gRPC service and my Xamarin frontend. So basically, my Xamarin Android application will talk to my API, or it will ask a question to my API, and my API has a direct connection using gRPC. So there's a service in between, and that's how I solved that problem, because at that time it was not possible to do gRPC from Xamarin directly. Because of this, when the front end wants to update the current temperature, it will ask the web API, what is the current temperature? And instead of using a cached value, the web API will immediately talk to the gRPC service on my Raspberry Pi. It will ask, what is the current temperature? The Raspberry Pi will ask the temperature sensor, and it will return the exact value at that moment in time. And then the API will send that as a response back to Xamarin. So again, there is one link in between, which is the web API, to make that work. So I hope that was an answer to your question. Of course, yeah. For today, I don't know, but yeah, in the future, more and more client platforms will support gRPC.
I just can't. I just need to ask you a question. What next after Sauna are you going to automate?
My entire house, basically. But it's also for me a very nice process to learn about all the things that are new in .NET. I have light bulbs that are connected to my Wi-Fi from a specific vendor. I have these plugs for power in the wall that are connected to my Wi-Fi from a different vendor, and I already searched for how to communicate with them. They all have internal web servers, so I can communicate with those web servers. So the next step would be to create one website, one web application that I can use on all my devices, where I can see an overview of everything that's in my house, my sauna, my different light bulbs, my different sockets for power, and so on.
Sounds incredible, but let's turn to the topic we have.
Yes.
Please continue.
So indeed, the past 75 minutes, I tried to talk to you about Web API, worker services, gRPC, project-i, configuration, logging, and how all of these things connect to each other. It was very basic, because of course we don't have much time. But in this second part, I want to continue with the same kind of services. So I want to continue with the Web API and the worker service specifically. Those are two services that can communicate with each other. And I want to show you how we can introduce Docker to this equation. So before we do that, let's show you what Docker can actually mean. So Docker is just a software application. So when we talk about Docker, it's actually something different than when we talk about containers. So Docker is just a software that helps us work with containers, but containers can also be supported by different kinds of software applications or cloud platforms. So Docker is just one of your options to make that work. But I think it's the most popular one. So that's why you hear about Docker very often. The idea of containers is actually the same as our real life containers. So when you look at this picture, you can see a large ship more than 100 years ago, so in the late 1800s. And when we wanted to put products and stuff on this ship, it was very hard to do because for liquids, we had barrels. For grain and food, we had bags. Sometimes we have crates, small crates, large crates, all different kinds of sizes of crates. And it was a lot of manual labor to put everything on top of this boat to make sure that everything fits, because some things are small, some things are large again. And well, with software development, it's just the same thing. We create different kinds of applications with different kinds of programming languages, different kinds of technologies, different kinds of computers, different kinds of operating systems. So there's so much stuff out there. And when we ask somebody, please deploy this application inside of your environment, there's so much things that we need to think about, just like when we were loading ships. Now, if we see the evolution of storage on like ships and trains and trucks, we can see that actually they've done things pretty cool. They've created a concept of a container, and it doesn't really matter if you need to ship a container using a boat or a train or a truck. They all have like a standard size of containers. You can just put a container from a truck on a train and from a train on a boat. It will always fit because the whole world is using the same standard. And for the people who are driving the truck or who are driving the trains or are driving the boats, they don't really care what is inside of the container. The only thing they need to know is this is a container. It needs to go from this point to that point, and that's it. And with software development, we want to do the same thing. We want to create software applications. We want to put them inside of a container so that the outside world really doesn't need to know how everything works in detail. They just need to know that this is a standard kind of container. It runs some kind of software, and there is some way we need to work with that. And that's exactly what Docker has been doing. So Docker is just a software application that is able to host a container, and we as a developer only need to figure out how to run our software inside of that container. And then there's a very small part where we can go from inside of the container to outside of the container, and from outside of the container to inside of the container. But that's the easy part. Of course, what we are going to do today is play around with a couple of containers. We make them be able to talk to each other. So it will look a little bit more like this image instead of this previous image. This looks very professional for a very enterprise kind of application. And this is what we are going to do today. So yeah, what's the concept of a container? Well, basically, you all know what virtual machines are. So we can have a physical hardware that basically runs virtualized hardware. And virtual hardware can be used to install an operating system on top of that, and we can install whatever software we want on top of that. A container is a little bit like that, but it's much more lightweight. A container is much more like a software package. It basically only contains your software and all of the dependencies, libraries, and configuration that go with your software. But it doesn't care about the operating system detail stuff or like the hardware drivers and stuff like that. So a product, a software like Docker, what it actually does is it creates one single virtual machine on your computer, and on top of this virtual machine, it is able to layer different containers, just like we put different containers on top of each other inside of a ship. So again, your container only contains your software application and all of its dependencies, libraries, and configuration. And then outside of your container is a virtual machine, which is managed by Docker. And then Docker will foresee that there's communication possible with your container if you need that. So you, as a developer, you need to specify if you host a web application, for example, that web application needs to be able to be accessed from outside of that container. So you need to open a port. And it's not like a firewall. It is a little bit like a firewall, but it's by default, nothing is open. By default, your container is completely closed. Nothing can go inside. You only can go outside. So if you really want a web application to be accessed by the outside world, you need to specify only this port can be accessed from the outside world. So that makes it a little bit more safe. Everything is closed by default, and you specify what is open. A container is not like a virtual machine, because the virtual machine lives outside of the container, which means that your container is pretty lightweight. If you shut down your container and you start your container again, it doesn't take half a minute. It only takes 1 second or even less than a second to spin up a new instance of your container. And that makes it very easy for cloud native development. As I said before, tomorrow we will talk about Azure Kubernetes Service, which will work with these containers. And if something goes wrong inside of a container, it will crash or it will be killed by Kubernetes. And then Kubernetes will instantly create another instance of that container to quickly create a stable situation again. And that will only take less than a second, so that the outside world doesn't really notice that something went wrong. Maybe if you don't do load balancing and multiple instances, if you only have one instance, then maybe a user will need to wait a little bit longer until a response will get back to him. Or maybe it will give him an error message like something went wrong, just try again. And if he tries again, it will work again. So that's very cool. Let's see. Yeah, there's also something called resource limiting inside of a container, which is also cool. You can really tell Docker if this container needs more than these specific set resources, then please just kill it, so that it doesn't really take down your entire virtualized Docker environment. So a Docker can really limit what it is using so that users cannot crash your entire server, for example. So very cool. Of course, something very important that you need to know about when using containers is that there shouldn't be any application state on your container. So if you're writing to files, or if you're using configuration files within that container, databases, stuff like that, that shouldn't really be a thing that you're doing, because when your container stops running, it kills everything. The memory inside of your container will be gone. The file system inside of your container will be gone. So the container goes down, everything is gone. So it only needs to be able to hold software. That software can be run. And if you want to store something, you always need to store your stuff outside of the container. So for example, if you're using SQL Server as a SQL database provider, then you need to use an external SQL Server. So you can use Azure SQL and connect with that, or you can have SQL Server running on a different server that you can access from inside of your container, but not inside of your container yourself. And so if you use, for example, SQLite or something like that, which is a SQL variant that holds like a little file next to your software, and you store your data there inside of a container, that's not good, because when the container goes down, your data is gone. When you spin a new version of your container, it will start from scratch. The file system will be empty, or at least only your software will be on top of that file system. If you want to do stuff like logging, you need to do logging outside of your container, not inside, because when your container goes down, all your logging will be gone. So very important. Docker and other software and Kubernetes, they all have things that you can use to do this. Of course, when you use SQL database, you can use connection strings to connect to other servers. When you use caches, distributed caches like Redis, for example, you just have another Redis container, or you have a Redis server and a connection string to that. You can use Azure Storage if you want to do file storage. Just keep everything outside of your container, basically. So let's go to some code and see what that looks like. So before I really dive into how to create your own containers, I'm going to go back to Project Thai. As you can see, I am really a fan of Project Thai. I think the idea is very powerful. Again, when you're writing multiple services and you want to run all of these services at the same time on your local computer, Thai can really help you. So what I did with step 8, so again, let me quickly repeat. If you go to my GitHub page, part 1 was the previous part of this workshop. Part 2 is what we are doing right now, so Docker. So we are now at step 8. So in step 8, I have my web API and my worker service. So it's the same thing as before. My worker service is a long-running background service that every second or every 10 seconds, it will call the web API, and the web API will return the computer name. So let me show you again very quickly. So this is my prepared version. It's a little bit more extensive. So it has a separate manager class, and this manager class returns the machine name. But it will return the machine name, but it will also include the current time. So hours, minutes, and seconds, just to show you that the caching actually works. And as you can already see, I am using a distributed cache. So when my worker service calls my web API every second, I don't want to return the new machine name. This is a stupid example, but if you have, for example, a service that really has a hard time getting the data, it's a lot of data, or it's a very complicated process. You don't want somebody to be able to pull everything down because it's calling your service multiple times per second. So you want to do some kind of caching. So that's what I'm trying to show you here. So I'm using a distributed cache, which is an outside caching. So it's not going to be cached in memory. It's going to be cached using an outside service. What I'm doing right here is first I'm going to ask to my cache, can you please give me the string with the machine name? And if that is empty, I know that it's not inside of the cache. So the cache doesn't know the machine name. When that is the case, I'm going to get the machine name from my computer. So this should then be your complicated thing that you need to do. Of course, getting the machine name is not complicated, but again, it's a stupid example. So this is something that can take a long time or is very resource intensive. I'm just putting in some timing, some hours, minutes, and seconds, so you can see that the caching works. And then I'm going to put this string inside of the cache. And I'm going to do that with a lifetime of 30 seconds, which means that the cache will be active for 30 seconds. And after 30 seconds, it will be cleared so that when you have a new request, it will be refreshed automatically. So basically, I want my data to be 30 seconds old at maximum. And after 30 seconds, I will get some new data. So when my worker service now calls my endpoint, nothing really changed here. But you will see that once in a while, it will get a fresh value. And the other seconds, it will get always the same value because that value is inside of the cache. So what you need to do to make this work is include a NuGet package from Microsoft, which is Stack Exchange Redis. So this is an implementation for a Redis cache. So this is an existing kind of caching service that you can use. There's different providers that you can use to have this cache. You can use that on Azure. You can host it yourself. You can have like a dummy version of that, whatever you need. But in .NET Core, it is something that you can declare in an abstract way. So here in my configure services, in my dependency injection, I'm just telling my .NET application, okay, you are going to use Redis cache, and you're going to connect with a Redis cache service using this connection string with the name Redis cache. So somewhere in my configuration, I can have a Redis cache connection string. And inside of my manager, I can just inject iDistributed cache. So again, this dependency injection, abstract cache, I don't really care what...
Jenny.
Yeah.
Sorry, I just heard you are going to return to Project Thai and asked engineers to an opportunity to ask you a question. We had a question about Project Thai in chat. Why I could prefer Project Thai for local development instead of Minikube, asks Vladimir.
It's a good question. To be honest, I really can't answer that question because I don't have any experience with Minikube. Or, for example, there's also Docker Compose. And Docker Compose, you can do almost the same thing with Docker. The reason I like Project Thai is because it's something that I started to use, and I just like it very much right now. So you don't really need to create containers for all of your services before you can use them. It will just run your .NET applications directly without the container surrounding them. So this I find helpful. I think in Docker Compose and in Minikube maybe also that you first need to containerize your applications before you can actually run them locally. But I'm not sure if that is true. So maybe you can correct me on that. So very sorry, I don't have a better answer to that question.
Oh, that's it. Thank you.
All right. So yeah, and basically this makes it a little bit harder for me to use something like Project Thai to run my application, because now I'm using an external service. I'm using a Redis service. So how am I going to do that? And so if I look at my Thai.yaml file, I can see that I still have the same cloud native application. It has my two services, my web API and my worker service. But now I have added two separate services. I've added a Redis cache and a Redis command line interface. The last one is actually not really necessary, but I'll tell you in a few minutes why I'm adding this. So there's two additional services, but I'm telling Thai that those services come from an image, and this is actually a Docker image. So the Docker image with the official name Redis will be downloaded automatically. It will be set up for me. I'm telling it that it needs to listen on port 6379, and it needs to have a connection string of the type like host and port. So this is the only thing I need to do. The only thing I need to tell Thai to say, okay, I need some kind of Redis cache. Please use this already existing Docker image, spin that up for me, configure that for me, and my service will connect to that cache. And basically, when you go back to the code, this little piece, it says get connection string Redis cache. It connects automatically with that configuration file from YAML. So it will actually use the connection string from this service. So this Redis service with this name has this kind of connection string, and that will be integrated in my web API. So when I go to my terminal and I do Thai run, it will now not only run my web API and my worker service, it will also run this Redis cache. It takes some time. I load the dashboard somewhere. Yep. And now you can see that there's 4 services instead of 2. There's my project web API, there's my project worker service, and there's my Redis container and another Redis container. So if I look at my worker service, you can see that every time it returns the computer name, it has the exact same time. So it's like 23 minutes, 56 seconds, 23 minutes, 56 seconds, 23 minutes, 56 seconds. And then it skips to 24:29. So you can see that it uses the cached value for some time, and then it refreshes the cache to the new time. And you can also see, and that's the reason why I have this 4th service. This is the command line interface for Redis, because then I can view the logging. And in this logging, you can see that sometimes, where is it? HM set. So here you can see with HM set that it's going to set this new cache value with this value. I'm sorry, no, with this value. This is the expiration. This is the actual value that's been put in the cache. Then it gets the value from the cache. It gets the value from the cache again. It gets one more time, and then it sets a new value. So you can really check your application that it uses the cache. It's working. You can see the logging. I'm a fan of this. So again, and you can also see that with this type. This is a project. It's not a Docker container. This is a Docker container. If you have Docker installed, Docker desktop, which is a prerequisite, you need to have that installed to be able to run this locally. And if I show you like this, you can see that it has these two Docker containers running for Redis, the CLI and the cache itself. Yeah, and then it also runs a little proxy container for my web API. And so basically it runs my web API in .NET, but then it has a little proxy container for that, so it is able to do communication between those services. But my worker service, for example, that it does not run in a container because it doesn't need HTTP communication, doesn't need a proxy. It can just run it by using the .NET command line immediately. So let's stop this again. So yeah, that's the last time I will mention Project Thai. Again, I don't have experience with Minikube or with Docker Compose. So I'm using this for my personal and professional project. It's also still in alpha, so it's not like a production-ready software. Project Thai can do also much more. It can also do deployments of your application to environments, can do continuous integration, but I have not yet tried that. So I'm not going to talk about that because I just don't have experience with that. The only way that I use it is for local development and local testing. So one more thing before I'm going to create my own containers is that since I'm using containers, life has become quite easy for me. Why? For example, for my Sauna application, I don't have servers running at home. The only thing that I've running at home on this local address is a NAS. It's a Synology NAS. It's like a bunch of hard drives that can contain some data, but it also has the opportunity to run Docker containers, and I'm really using that a lot. So I have a lot of stuff running on my local NAS. This is, for example, a web API for my Sauna application. It runs locally, so I don't have access from the outside world. I only have access from within my local network. And because I deployed that using a Docker container and I put that on a public Docker registry, that image is available there. I can just, inside of my NAS, download that image and run that as a container. I don't have to do any configuration. My NAS runs Linux, but I'm still able to run .NET applications perfectly fine within this Linux environment, and I can call this API from within my network. I can't really remember the actual port. I think it's going to be 8081 or something. Nope. Whatever. I can't remember. Doesn't matter. But I can reach it from within my local environment. But then for my Raspberry Pi, it's a little bit different. My Raspberry Pi will not run a Docker image. It will run the actual .NET service in systemd, but I'm using Docker for something different. When you are creating pipelines in Azure DevOps uses the concept of an agent. And an agent is a little piece of software that can run on a server, and that software will pull your code from GitHub or from whatever Git repository. It will build your code, and then it will have some report of that build process. But I don't want the outside world to access my internal network. So what I did is I installed Azure DevOps agent on my NAS server, which is this one. It's not running right now because I need to have a newer version installed. But this pipelines agent now runs inside of my network. And this agent has access to my Raspberry Pi in the same network. And I can use my public Azure DevOps pipeline. And when I'm selecting an agent, basically an agent is not contacted from outside. An agent, it works with pulling stuff. So the agent runs in my local network, and it will ask Azure DevOps, do I need to do anything? And Azure DevOps will respond to that. So this actually makes sure that there is no connection from the outside world. Everything within my local network is only accessible within my local network. The Azure DevOps agent, which runs in a Docker container on my NAS, runs in my network, and it asks Azure DevOps for some information about building and deploying my stuff. So I think it's very powerful that I can now basically put on my NAS whatever I need. Other examples that I'm using is I am running a SQL server inside of a Docker container on my NAS. So all of my local SQL Server databases, they are on my NAS, and I don't have to worry about my data being in the outside world. And I told you before, don't put SQL Server databases inside of a Docker container. So what the hell am I doing here? Well, when you configure a SQL Server, you can do volume mappings. And a volume mapping basically tells your container, this folder inside of your container maps to this folder outside of your container. So when your container writes something to that folder, it actually writes it to somewhere outside of the container. But this is also optional, so it's opt-in. Just like with the communication ports for HTTP, you need to configure this internal server. This internal path maps to this external path. And now when I stop and restart this Docker container, everything inside of the container will be removed, will be destroyed, but the data that still lives outside of the container will still be there. This is probably not a good idea for production environments, for like professional use. You really need to use like a dedicated SQL server or like an Azure SQL to store your data. But for my internal home usage, this is perfectly fine. The data is on my NAS. It also gets backed up automatically. So for me, the concept of containers are really powerful. I also have Elasticsearch running on my NAS. I have another kind of SQL and so on. So let's stop with this and go back to code to actually build containers. So the next thing I want to show you is step 9. And with step 9, I still have my web API and my worker service. And I want to be able to run these inside of a Docker container. So how does that work? What do you need to do? There are some plugins you can install for Visual Studio Code to be integrated with your local Docker environment or even remote Docker environments. So on the left-hand side in Visual Studio Code, depending on which plugins you have installed, there can be a Docker and Kubernetes icon. So here you can see a Docker icon. If I click that icon, you can see 3 different things. You can see containers, images, and registries. So what is the difference? An image is an image that contains the description of your container and your software. So it's like a NuGet package, basically. A NuGet package also contains some code and some metadata to describe what your image actually does and what it is and who made it and stuff like that. A Docker image is the same thing. It contains a description of what your container does, how it should do it, and it also contains a copy of your software and all the dependencies and stuff like that. This is something that you need to build. This is something that you need Docker to build for you, and then you can use it. You can see that there's already a lot of containers on my local system. Most of them are from Kubernetes. And then one is the Redis image that I've used in my Project Thai demo from a couple of moments ago. And that's it. Containers are your images that are actually running. So these are running containers. And at the moment, there's nothing running on my local system. And then registries is basically a place where you can put your images publicly or privately. So Docker itself has a Docker Hub, and Docker Hub, there you can put your Docker images publicly, and that's what I do. That's what I'm doing for my Sauna application. And my Sauna web API is on the public Docker Hub, and I'm pushing it to Docker Hub from my build pipeline, and I'm pulling it from Docker Hub in my release pipeline in Devops. So I'm not using a private repository. So basically, you can just download my Docker image and you can use that for yourself. I'm not sure if you're going it's going to be useful to you, but for me, it was easy to put it on a public registry. But in Azure, you can create your own private registries and use them for your private projects. So that's all. That's the thing that we are going to do today. So if I go to my code, there's even more additional plugins in Visual Studio Code that can help you to create these containers. So if I'm, let me just close this and only open the web API in Visual Studio Code. Basically, the working directory is very important when you're doing stuff like this. So I'm just opening the web API as a folder so that I'm in the correct location. And Docker needs you to create a Docker file. This Docker file is a description of what your container should look like and what it needs to do. So if you have a .NET application, you can use a plugin and use Docker to add Docker files to your workspace. So I am now inside of my project, inside of my web API project. I'm using this command, add Docker files to workspace, and it's going to ask me some questions. What kind of application do you want to put in a Docker container? Is it like a .NET application, a Python application, a Java or C++ application? In our case, Web API is a .NET ASP.NET Core kind of application. So I'm going to select this option. Then it's going to ask me, what kind of operating system do you want to run? So I didn't talk about this, but when you're using Docker, the virtual machine that's being managed by Docker it can be Linux or it can be Windows. You can choose that. If you install Docker, it will ask you, do you want to have Linux containers or Windows containers? I always pick Linux containers. Because .NET runs on Linux. Linux has the most support in the entire cloud industry. There's Linux everywhere, so I think Linux is the most flexible choice. So my Docker on my local system is running Linux, which means that my containers also need to be Linux. So I'm going to choose Linux. And then it knows automatically, it can see you are running a web API. This web API uses port 5000 by default. Do you want to expose this port in your container? So in our case, yes, I want to expose port 5000 because I want to have external access to my container. So I'm going to accept this 5000. And now the Docker file will be created. So this is Docker Compose, what I was talking to you about before. You can use Docker Compose to have multiple Docker files at the same time to do something similar to Project I, but I have no experience with that, so I'm going to pick no. I'm going to make it generate this Docker file, and this is now kind of a script that tells us how it needs to create and run our image and container. So let's go through this from top to bottom. So the first line is basically a dependency on another Docker container. So Docker containers, they use the concept of building on top of other containers. So if you are hosting a .NET application inside of a container, you have some dependencies. The dependencies that we have is .NET. There needs to be a .NET runtime, because otherwise our .NET application cannot run. So that's why I'm going to tell Docker, please create a new Docker image from an existing Docker image. So I'm going to use the ASP.NET 5.0 as a base image for my container. So Microsoft already created a container which contains the runtime for .NET, and I'm going to put my software on top of that. So you always have like a base image. The cool thing about this base Docker container from Microsoft is that it already has the runtime. It has like the Kestrel web service that it can use, and the Kestrel web service has its own dependencies, like specific drivers for Linux to be able to use networking stuff. So all of that is already taken care. So I just built my software on top of existing software, the .NET platform in this case. The second line tells Docker what is the current working directory. So your application will run from some kind of working directory, which is the /app directory. So in Linux, / is your root file system, and then app will be my directory that contains my application. And then I have my expose. So expose is this thing that exposes port 5000, HTTP port 5000, or TCP port 5000, I mean, to the outside world. So now for the outside can connect to port 5000 inside of my container. This is an environment variable from ASP.NET Core. It tells ASP.NET Core to use port 5000 internally. And then there's some additional stuff that's automatically been added for me. It will create a user, and it explains it on top. So instead of using like a root Linux user to do all of this stuff, it creates a separate user that doesn't have a password and so on. It's not very important, but it's going to use that user for the next lines. And now something weird is going on. It's using another Docker image. So actually, this works in multiple steps. So this base image will be the image where my Docker container is based on top of. But instead of using my software from my local system, so I don't have to publish my web API on my local system and copy it to my container, I'm going to do it differently. I'm actually going to pull another Docker image, which is the SDK and not the runtime. This is the runtime. This is the .NET SDK. So now I have a second Docker image. And this Docker image has a working directory called source, and it will copy everything from my local environment. So all this directory on the left-hand side, all of this, it will copy that. It will copy the CS project file, and then it will run a .NET restore on my CS project. So .NET Restore will restore all the NuGet packages, all the dependencies. Then it will copy all of the files. It will set the current working directory to that source directory. And then it will run a .NET build. So it will build my application in the release configuration, and it will push that to the build directory. And then it will do another .NET command, publish, and it will publish to this publish directory. So basically, why are we doing this? We are using a separate Docker container to publish my application instead of publishing it on my local environment. And this is always a good idea. It's also a good idea when you're doing continuous integration that you're using containers for your builds and your releases, because you always have a clean environment. If we do from .NET SDK, we always have the latest and cleanest .NET SDK environment. So it's not polluted by other things. So we know that our publish and our build will always be clean, always from scratch. There's no residual data, there's no residual files that can cause problems. We always start from scratch. So when that publish has been successful, we go back to our base image, which is the one we created beforehand. We change our working directory back to the app directory, and then we copy all of the files from the publish directory into this app directory. So basically, from one Docker image to the other Docker or container to the other container, we just copy all of those files, and this is my final release version of my published application. And then finally, we will tell Docker, when you start this image, the entry point for this image will be this DLL file, and you will need to use the .NET command line tool for that. So in .NET Core and .NET 5, when you run a web application, it doesn't have an executable. You always need to host that inside of a web server. In .NET Core and .NET 5, that web server can also be hosted by Kestrel inside of that console application. So you can just call .NET and then your main DLL, and that will spin up that Kestrel web service automatically. So this is now a complete description on the different steps we need to follow to create this Docker image. So the only thing you need to do is right-click inside of this file and use this command, build image. So when I click build image, in the bottom, it will open a terminal, and it will start to execute all of these steps. There we go. And I think that's it. Yeah, that's it. All of the steps are completed. You can see the descriptions, loading the build context, setting the work directory, copying the files, and so on. So that was pretty quickly because I already did it beforehand. It can be that if you do this for the first time, that it takes a little bit longer, because these images, they need to be downloaded from a public registry. And so this public registry is called mcr.microsoft.com. And those images need to be downloaded to your local system, but I already have them. So if Docker needs an image that you already downloaded in the past, it's cached and you don't need to re-download it from scratch. But if I would remove it, it needs to re-download, but it will do that automatically. Now my image has been built. So where is it? Well, inside of my local Docker, I now have within my images this web API image, and within that image I have a latest tag. It's a little bit weird because it tells me that it's 20 hours ago that I've created this image. That's because 20 hours ago I prepared this and I created the image. But if you delete the image from here, sorry, if I delete the image from my local system, now it's gone, and I rebuilt it, Docker knows that there were no changes. And so when I prepared yesterday, I did not make any changes. So when I'm recreating the image, Docker knows that it hasn't been changed since 20 hours ago, which is actually pretty cool. Now, this is an image. You can do different things with an image. You can just leave it on your local system. You can push it to a registry, which means you make it available for the outside world or whatever other software you want to use that pulls from that registry, or you can run it locally. So let's first try to run it locally. So when we right-click the tag, you can choose Run. And when you choose Run, that image will be started with default parameters, which means the image itself exposes port 5000. And basically, it works with like port forwarding. Your local computer has ports available, and you need to do some forwarding from my local system. I need to forward to the internal port 5000 of my container. And for example, if you have 10 different containers and they all expose port 5000, you cannot use them all at once. If you use that port 5000, that's why we need some port forwarding. So we're going to use another port that redirects to port 5000 within the container. But if you don't do that, and if you just right-click and click Run, then your container will run with the default port. And you can see that here, 5000 local points to 5000 internally in my container. So that's it. This container is now running. Port 5000 outside is mapped to port 5000 internal, which means that if I open my browser and I do local host 5000 status, this is now the same application that returns my machine name, but it now runs inside of that Docker container. And you can see that because the machine name is different. The machine name is like a part of a GUID. It's like a unique identifier for Docker, and it's not my computer name anymore because my .NET code now runs inside of my Docker container. So it's like a specific environment. It's a specific machine name. It's a different environment. It's like a little small virtual machine. Very cool. Let's go back to Visual Studio Code. So this is my container running. Again, if you like to see what is happening with logging and stuff like that, you can right-click a running container and do View Logs. And this will automatically connect your terminal in Visual Studio Code with the internal terminal from your container. So now you can see that indeed it has started an ASP.NET web API, and I have some logging. My status controller logged this request that I did before from my web browser. So you can just see what's happening right here. So that looks good. So let's go to my worker service. So if I look at my worker service, and I open my worker service inside of Visual Studio Code, it's the same thing. Yeah, I already prepared these files, so I'm just going to delete the Docker file and I'm going to generate a new one. So again, I'm using the extensions from Visual Studio Code. I want to create a new Docker file for this project. Now I have to be very careful. I have to think, this is a worker service. A worker service is not a web application. So it's not an ASP.NET application. It's a console application. So I'm going to use another template. I'm going to use the .NET Core console template. I also want it to run on Linux. And I don't want to include Docker Compose files. And there's my second Docker file. So this is the description for my worker service. You can see that it's pretty much the same thing, but it doesn't use the ASP.NET image. It uses the .NET runtime image. This one is smaller. ASP.NET uses lots more. ASP.NET needs a web server. It needs the dependencies for a web server to be able to run. The .NET runtime is smaller. And basically, the .NET, all of these Docker containers, they are like onion layers. And so somewhere there's like a base image, and then there's another image that uses that base image. And .NET also uses the same system. The .NET ASP.NET image actually is based on this image. So this image is a dependency for the ASP.NET image, and ASP.NET just adds some information to the default .NET runtime. So it's one image is built on the other image. But for this, for running a console application, we don't need all of that ASP.NET stuff. So we are using this image because it's smaller in size. A smaller image means less time to deploy, less time to start, greater performance for your application. We're doing the same things here. We're using the .NET SDK to build and publish our code, and then we copy it to our actual final base image, which is the .NET runtime. By the way, these intermediate images, they will be deleted. So they are created on the fly to build your application, and then they are deleted again, and you only have your final image as a result. So I can do the same thing. I right-click. That's not entirely true. Sorry. There's one thing I need to add. I didn't show you this, but of course my worker service needs to communicate with my ASP.NET service. So it needs some kind of configuration. In Docker, the easiest way to do configuration is by using environment variables. An environment variable, so if you have like a system, a virtual machine or a server, if you add environment variables to that server, those variables are usable for all of the software that runs that server. In Docker containers, we have the same thing, but your Docker container typically only runs one part of your application. So if you want that part of your application to be able to access some kind of configuration data, you put that inside of an environment variable for that container. So this is my code. So there's app settings.json. There's my web API service URI. It will work perfectly fine if I leave it here, but I need to change this value. But I'm going to do it a little bit different, and I'm going to show you the code for that. In my program file, if I add these lines of codes, so add environment variables, I'm actually telling the configuration builder for .NET, if somebody asks for a configuration value, you need to take that configuration from app settings.json, but also the environment variables. So they will be combined. So inside of my code, inside of my client, I'm using configuration.web API service URI, but I don't really care where it comes from. It can come from app settings.json, but it can also come from my environment variables, which means that in my Docker file, I can just add one line of code. I forgot the actual line itself. So I'm just going to quickly cheat and look at my repository in GitHub. And that's why I created this. So to help you guys, so that you can take a look at this code, but I can also help myself. So here's my Docker file. This is the thing that I need to add. So this line tells me that my Docker container has one environment variable called Web API Service URI, and this is the value. And this is a little bit tricky, of course, because I'm now running on my local computer. This Docker container needs to contact my other Docker container, but I can't use localhost. I can't say localhost because localhost is inside of your container. Localhost is not my laptop that I'm using right now. Localhost is the container that's running the worker service. So I need to go outside of localhost. And yeah, Docker just has this thing. This is like the DNS name for the host, which is the Docker host itself. And so my host environment, which is my laptop, has port 5000 linked to that other Docker container, and that's why they are able to communicate to each other. Tomorrow, when we are talking about Kubernetes, you will see that in Kubernetes it's much easier. in Kubernetes, we can create services and then talk to services directly, but that is for tomorrow. So yeah, I've added the environment variable, and now I'm going to build the image. It's the same thing. We need some steps here. It will take a couple of seconds, so I can drink something. There we go. And now, if I again go to my Docker extension, I can see that there's a new image called worker service. This one is also created 20 hours ago because I prepared for 20 hours ago. I can right-click and I can run. This will run that container. In the top, you will now see my worker service also running. And if I did everything correctly, this doesn't need any ports because it's not a web service, it's just a console application that now runs inside of a container, and it calls outside of the container into this container. So the only way that I know that it's working is by looking at the logs. So I'm just going to do view logs. I have no idea what it's asking here, so did I? Okay, that's it. Please go away. Thank you. So in the bottom, we can now see the internal logs for the worker service container, and you can see that it's running and it's calling the other container which has the name 7127 and so on, which is basically the same thing that we saw before. If I run this from my local browser, localhost 5000 status, it's the same thing. It's the same name. And that is how you create containers, run containers locally, and do some small configuration on how they need to contact each other, stuff like that. If you don't have experience with Docker, for example, on my NAS system, when you run a container, all of the stuff that I'm doing right now is basically command line. I'm actually I'm actually using extensions within Visual Studio Code. I really like these extensions, like add Docker files. It's like a wizard. It asks me questions. I answer those questions, and it will do everything for me. But if you're using Docker, you can also use that from the terminal. Basically, all of the things that I'm doing are like Docker command line tools that you can use, like Docker build, Docker image, Docker volume, Docker kill, all of that stuff. You can find it online how you do it from command line, but I always forget because I can't remember all of the different commands. So that's why I like to use these tools from within Visual Studio Code. But if you are running this in a pipeline, like an Azure Devops pipeline, for example, and I can actually just show you. So dev.azure, yeah, this one is also fine. This was not my Sauna application, but the game for C# Wars. If you look at this pipeline, the details, where are the details? Yes, so here, it's a bunch of command lines. And they all do these kinds of things. So this one, I can't really see the command itself, but you can see that I'm just running the same thing from within a pipeline. I'm calling Docker build, and this will actually pull these base images and all this stuff. So you can use that from command line for your automatic pipelines, release pipelines, whatever you want. Okay. The final step would be to put these images on Azure and to try to run them on Azure. So I'm going to go to my Azure environment. So now I have my images on my local machine. If I want to run them on a cloud environment, I have many options. I think all large cloud environments and even smaller cloud environments have support for containerization. So you will be able to run your containers on different kinds of clouds. I am using Azure as an example because I'm most familiar with Azure. So what I already did, is that I created a resource group on Azure. And so a resource group on Azure is like a collection of everything that I want close to be close to each other. And so for this cloud native workshop for .next, I've created a separate resource group. What I'm going to do is I'm going to add a new resource, which is called the Azure Container Registry. No results were found. So I think it's just Container Registry then? Yes, Container Registry. So a container registry is kind of a storage service that just stores Docker images. And then you can use these Docker images in Azure because now you have access to those images from within your Azure subscription. So I'm just going to create this thing. I put it on my subscription. I put it in my resource group. I need to give it a name. So this is going to be Donica for .next. It needs to be a unique name. A unique name because it's like a public URL. A public URL that I can use to push and pull images from. I need to put it somewhere. I'm just going to put it close to my home, which is West Europe. And I'm going to leave the other things by default. And I'm going to create. So this is just an empty box, a registry, that is able to hold my container images. So I'm going to give it some time to deploy. It's complete. I can go to my resource. And this is now my container registry. So this can now hold my containers, and you can see that I have included 100 gigabytes of storage. So let's go back to Visual Studio Code. You can see that I have my 2 local containers running, which is fine. I'm just going to keep them running in the background. And then here I have my images. And then in the bottom, I also have registries. So registries, you can link to an existing registry. So I can click Connect to Registry. Again, this is a wizard. You can do this from command line, but I like to use these extensions in Visual Studio Code. So it asks me, where is your registry located? Is it on Azure? Is it Docker Hub? Or is it some other kind of Docker registry? Or is it GitLab? So in our case, it's going to be Azure. So if I open Azure, so basically my Visual Studio already knows my subscriptions in Azure. If you want to use Visual Studio to connect to your Azure, you need to do something like Azure login or something. Azure, I can't find it. There is an extension where you can link let's disconnect from Azure. See if I can show you. No, I can't show you. Okay, but if you're doing this by yourself and you do connect to Azure and Visual Studio Code does not have a connection to Azure, it will ask you with a pop-up to log into your Azure from your browser, and then it will redirect to Visual Studio Code and give you access to all of your subscriptions. So I'm using this subscription, and then will automatically filter out all of the registries on your subscription. So this is the registry that I created just now. If I open this registry, you can see that there's nothing inside, only tasks. Now, if I want to push my Docker images to this registry, I can do that also with this plugin. I can right-click my web API image, tag, right-click, push. He will ask me, where do you want to push it? This subscription, this registry with this proposed name. Enter. It's logging in, and it starts to push the image. And by the way, here you can see that my Docker image exists out of multiple layers. And these are like the onion layers I was talking about. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 layers. So the last one, this layer, is my .NET application. The previous layer is the .NET runtime, or at least the ASP.NET runtime. The previous layer is the .NET runtime, and so on. So you can see that there's multiple dependencies. And then when everything's finished, and I refresh my Azure registry, now my web API image is also on my registry on Azure. So let's do the same thing for my worker service. So my worker service, I can right-click and I can do run. I'm sorry, right-click and push. The same stuff, and it will be pushed. Now something very interesting will happen. It was, by the way, it was the other way around. The top one is my code, and then it goes from top to bottom. I told you it was from bottom to top, so that was wrong. So now you can see that the top layer is my layer that's being pushed, and then the layer below that is mounted from Web API. So if these are onion layers, some of these layers will be equal. So my Web API, my worker service, they are using the same layers because the .NET runtime is going to be the same for both. So instead of uploading that image again, it's going to reuse that same image from another container. So it will reuse to optimize storage and stuff like that. So it's very cool. And if I reuse one more time, if I refresh one more time, you will see that now I have two containers, two images on my Azure registry. So let's go back to Azure. If I go to repositories, I can now see that I have two images. I have my Web API image and I have my worker service image. You can look at the details and you can see the tags. I didn't really talk about tags, but tags are useful for versioning. If you are pushing the same image but a newer version to your registry, it will have the same name but a different tag. So latest is the default tag for the latest version, but you can have like a whole history of all of your older versions within that same repository. So a repository contains multiple images, and all of the images have different versions. So in our case, it's only the latest version that we have pushed. If you push another version with the same tag, it will just overwrite, but you can rename your tags and then you can push as a different version. From Azure, there's different possibilities to run your Docker containers. The one that I think is easiest for this demo is I can run it from here. And so here I can say run instance or deploy as a web application. In order to be able to do that, I need to have an admin user enabled for my registry with some passwords. So this is just something that you need to do just for this demo. If you're using like Kubernetes tomorrow, we don't need this. For Kubernetes, we are just going to pull from this registry immediately from outside, and then it will work. But now to demo, to run from within the registry, I need to enable this admin user. So if I go back to repositories and then Web API, click this tag, I can now deploy this as a web application. And so if I do that, Azure will automatically create a new web app, which I can give a name. For example, cloud native .next web API. This subscription, this resource group, I have prepared an app service plan. This is going to be my image. I'm going to run it on Linux and create. So what is happening right now is that Azure will use this image as a base for a web app. So instead of deploying my .NET web app immediately to Azure, I'm just going to use a container instead, because Azure's web apps or Azure service apps, they support Docker containers. So now I have to be a little bit patient for this deployment to finish. And actually, while it's doing this, I'm also going to deploy the second one to another web app. I can host it as a web app, but it doesn't really have a web page, but that doesn't matter. It will just run my application in the background. So cloud native .next worker, same service plan, Linux, create. Yep. So now they are deploying. So let's go back to my resource group, cloud native .next. This is my web API app service. And if I'm patient, this is my public URL. And if I do /status, it needs to start, so it can take some time if I deployed it like this. It should show me the machine name successfully. So let's be a little bit patient. Yeah, I told you before, this is very cool stuff because it's very fast. If you deploy it like this in an app service, it's not so fast the first time, but once it's ready, it's a lot quicker. So this is now my machine name inside of an Azure app service that runs a Docker container, and then the final thing I need to do is wait for my next deployment to be finished and to do some configuration, basically. So I have my worker, and it's the same thing here. I need to set that environment variable. And in Azure, that's very easy. If you go to configuration for an app service, these are my application settings. I can just add an application setting. This is where my web API is hosted. This is the public URL for my web API. I forgot the name for my parameter, which is this one. That. Okay. Save. So now my worker knows where to connect to. And just to be sure, I'm going to restart this app service. Then it will restart my Docker container. It will read that environment variable, and it will be configured correctly. So we only have 1 minute left. So I hope when I look at the internal logs, so on an app service, you somewhere have the possibility to have advanced tools. Go to your advanced tools. This is like some internal stuff that you can use for your running app service. So you can have SSH inside of your app service. You can have a bash inside of your app service, but you can also look at the log stream. And this is the log stream for my internal Docker container within my app service. And you can see that it's connecting to my other container, because here every second it will log the machine name. So it works. So now I have my 2 containers running inside of Azure App Services. But of course, when you need to do this manually, it's very hard because you need to configure all of your containers manually. You need to create all of the resources in Azure manually, or you need to create some kind of script or pipeline to do that for you, which is a lot of work. So tomorrow, we will do the same thing, but we will do it inside of a Kubernetes cluster. I will talk to you about how that works, what it looks like, and I will show you with lots of demos. So thank you. Any questions?
Thank you, Johnny. We will discuss some actually, we don't have questions in chat, but I think I have several questions of my own, and I can't wait to ask them.
Okay, perfect.
Thank you, Johnny. Thank you, Anna. If you want to discuss any questions, you could join to discuss zone and discuss some questions about this talk.
Okay.
Bye, Johnny. Bye, Anna.
Thank you. Bye-bye.
Bye.